This is the video for the mass of a gas lab. Now everything you need is pretty much what's shown here. You need your packet, you need a beaker, you need the electronic balance, you need a vial. It's filled up about a third of the way, so around 15 milliliters with water would be fine. You need the cap with a little piece of Alka-Seltzer taped to the top. Now what you want to do when you're working on the lab, pay attention to what it's asking you in the lab. It wants you to make some observations before and after dissolving. When I ask you for observations, I'm fine if it's not some super complex observation, but the words you pick should be very descriptive. If you're talking about the Alka-Seltzer, write the Alka-Seltzer. Don't just say the stuff or the thing or whatever. Use the words. If you're talking about the liquid, write down the water. All right. Be descriptive. They don't have to be real long observations, but you should use descriptive words. We're only going to do one trial per group, and pay attention to what it's asking you for. It wants the mass before the reaction, after the reaction, the change in mass, mass after releasing the gas, and mass of the gas in the vial. So there's two different ways you could do this, and it depends on if we have enough balances. One way is you put the balance or the beaker on the balance and you tare it so it's reading 0. And then you put the vial and the lid how they are. You don't want the cap on the vial yet. And you would write down the mass for that. And then you would compare that when you're done the reaction. Now, if you have your own balance, what you could do if you wanted to is put everything on there and hit 0. Right? It depends on how many balances we have. And now what you're going to do, and this is where people will make a mistake, or it'll be easy to make a mistake. You want to get this lid on top of the vial as tight as possible. So when you tip this over, get that as tight as you can. And you want to tap that on the countertop, and it's going to start reacting. Now this is an old piece of Alka-Seltzer, so it's not reacting that fast. And you put it on the balance. When it's done reacting, and you'll know that when it's done because it won't be bubbling anymore. So this one is still going. When it's done reacting, you're going to write down the mass. Now whether you had just the beaker tared or everything tared, you're going to write down the number that's on the balance. And then you're just going to do a subtraction to get the change in mass. All right, now, at this point, this is a closed system, as long as this cap is on there airtight. Right, now, when you release this, and I'm going to do this before it's done, because we're not going to wait for it, but when it's done, you won't see any more bubbling, you're going to release it, and you might hear a little bit of a noise at this point. No, I didn't let enough gas build up. And you're going to put that back on the balance, and you're going to write down the number. That's what you get for mass after releasing gas. And then you do a little subtraction for mass of the gas in the vial. Now, what we're going to end up doing is collecting the class data for change in mass. Did it go up? Did it go down? Like, what happened there? Right? And then we're going to have a little discussion about open systems versus closed systems, and we're going to make a histogram. It is a certain type of graph where we can basically compare everybody's data. But that's the way this lab goes. Overall, it's pretty straightforward, I think. Just make sure that cap is on there as tight as possible before you put the Alka-Seltzer into the vial. Okay, the histogram is going to let us graph the change in mass using the classroom data that we collected. So the first thing we want to do is label the axes. For the y-axis, it's going to be number of data points. Alright, now we could just start labeling these 1, 2, 3, 4, 5, and just keep on going up. For the x-axis, you want to go somewhere in the middle, and this is going to end up being change in mass. Alright, so I'll just go right about here, and I'll say that's 0. So let's make sure we label this change in mass, and that will have the units of grams. Okay, now going left and right, I'll fill this in as best as I can, but I don't have a lot of room here the way I'm doing this. So let's say on the right hand side, that's where we'll have positive changes in mass. So this first box after that 0, we can make it 0.01. So say someone's mass went up by 0.01 grams, that's where we'd put a box. Or if they went up by 0.02 or 0.03 and so on. Now on the left hand side, it's just going to be going negative. Negative 0.01, negative 0.02, negative 0.03 and so on. You can fill in more of those. So when we're collecting the class data, let's say we had 3 groups that went up by 0.02. What you would do is go up to where it has 3 groups and you'd fill in this 0.02. And let's say we had, I don't know, 4 groups that didn't change mass at all. We'd put that in there. And then maybe 2 groups that went down by 0.02. Right, so it's a way to visually represent what all of the data was for the classroom. Right, so when you look at this, for example, like I said, 2 groups, their mass went down by 0.02. 4 groups, their mass stayed the same. For 3 groups, they went up by 0.02. Right, so this is change in mass for the experiment when it was a closed system.